Hello everyone, this is Lohith. Today I'm going to explain S-attributed grammars and their application in expression evaluation. This topic is part of automata and compiler design, and in this presentation we will understand synthesized attributes and how bottom-up semantic evaluation works in compilers. Introduction to grammars. Let's start with grammars. A grammar is a set of formal rules that defines the structure of a programming language and specifies how valid statements are formed. In compilers, grammars play a very important role because they help in parsing the source code and converting it into a parse tree, allowing the compiler to understand the structure of the program. Syntax-directed definitions. Now let's move to syntax-directed definitions. A syntax-directed definition, or SDD, is a grammar extended with attributes and semantic rules. Instead of just checking the structure of a program, it also performs computations during parsing. In simple terms, SDDs connect syntax with meaning and help the compiler compute values as it processes the code. Attributes in SDD. There are two main types of attributes used in syntax-directed definitions: synthesized attributes and inherited attributes. Synthesized attributes are computed from the child nodes and flow upward in the parse tree, while inherited attributes are passed from parent or sibling nodes downward or sideways. In this topic, we mainly focus on synthesized attributes. Attributed grammars. S-attributed grammars are a type of syntax-directed definition that uses only synthesized attributes. This means all values are computed from child nodes and passed upward to parent nodes. This bottom-up approach makes evaluation simple and efficient, and it aligns naturally with bottom-up parsing techniques. How S-attributed grammars work. In these grammars, evaluation starts from the leaf nodes of the parse tree, which are usually tokens. Values are computed step by step and passed upward until the root node is reached. This is known as bottom-up evaluation. These grammars are compatible with bottom-up parsers like LR parsers and do not depend on parent or sibling nodes, making them easier to implement. Expression evaluation example. Let's take an example expression. 3 plus 5 multiplied by 2. According to operator precedence, multiplication is performed before addition. So first, 5 multiplied by 2 gives 10, and then 3 plus 10 gives the final result of 13. Grammar for arithmetic expressions. To evaluate such expressions, we define grammar rules such as E produces E plus T produces T multiplied by F, and F produces a digit. These rules ensure that multiplication has higher precedence than addition and make the grammar suitable for bottom-up parsing. Semantic rules. Along with grammar rules, we define semantic rules to compute values. For example, if E produces E1 plus T, then the value of E is the sum of E1 and T. Similarly, for multiplication, the value of T is obtained by multiplying T1 and F. For digits, the value is simply the number itself. These values are propagated upward in the parse tree. Step-by-step evaluation. Now let's evaluate the expression step by step. First, we read the digits 3, 5, and 2. Then we compute 5 multiplied by 2, which gives 10. Finally, we add 3 and 10 to get the result 13. This shows how evaluation is performed in a bottom parse tree with attributes. The parse tree represents the structure of the expression, where each node has an associated value. The leaf nodes contain digits, and internal nodes compute values based on semantic rules. These values are calculated from the bottom of the tree to the top, and the root node gives the final result. Advantages. S-attributed grammars have several advantages. They are simple to implement because they use only synthesized attributes. Evaluation is efficient since all computations are performed in a single pass. They also provide a clean and structured approach to semantic analysis and work well with bottom-up parsing techniques. Limitations. However, S-attributed grammars have some limitations. They do not support inherited attributes, which means they cannot pass information downward in the parse tree. This makes them less flexible for complex semantic tasks, such as type checking or scope resolution. Real-world relevance. In real-world applications, S attributed grammars are widely used in compilers for expression evaluation. They help in semantic analysis and support efficient code generation. Their bottom up approach and effective in modern compiler design. Thank you. That's all from my side. Thank you for listening to my presentation. I hope this helped you understand S attributed grammars.